Welcome to this section. In this section, we will discuss how iterator can be used along with collections. And we will go through the methods provided by them and we will understand how those methods work. And I have opened IntelliJ IDEA here. Let's create a new project. Java, clicking next. Clicking next. Project name, Iterator Demo. The project has been created. Under source, I'm going to create a package. The package has been created. Now let's create a Java class. The Java class has been created. Now let me add the main method. The main method has been added. Iterator works with collections. So first let's create a collection. I'm going to create an array list of integers. It's an empty array list. Let's insert some values into array list. You can always format the code by clicking code, reformat code. This is an option in IntelliJ IDEA. Now let me insert the data into a list. A list.add of I. So we are inserting the numbers from 1 to 10. Now let's print this array list using enhanced for each loop. We have been using enhanced for each loop so far. For integer and a list. So as I have said previously, integer is the data type an array list holds, and n is the temporary variable which holds integer. Now let's print it here. Now let's run this program. Yeah, the array list has been printed. Now we are using enhanced for each loop. Now let's see how can we use iterator to traverse this array list. Okay, so I am removing this piece of code. I hope you know how to obtain the iterator. We already have discussed how to obtain iterator. So it's very easy. Iterator. Now we have to pass the data type here. The data type should be same as the type which array list holds or the collection holds. So collection holds integer here. So integer. Let's import this. Java.util iterator equal to. So how can we obtain the iterator? Every list has an iterator method which will return an iterator. So a list dot iterator of. So we have obtained iterator in this variable. Now let's see how can we traverse this. So if you can remember the methods that we have discussed for iterator, there are 4 methods and we can use iterator dot has next. If there is a next value, it is available, then iterator.next of. So basically we are checking whether the iterator have value or not. If there is a next value available, then we are pulling that value here. Now let's run this. I'm not expecting any change in the output. Yeah, one change is there. We briefly to add a space. Yeah, so we have learned two methods, have next and next. To understand the behavior of iterator, I'm going to do an experiment here. Now, when we are running this program, what will be the output? Let's see. Did you see the 1, 2, 3 has been missed out? The reason is this: when the next method is called at first time, iterator is pointing to 1. It is now pointing to 2. When it is called again, it is now pointing to 3. From 4 to 10 will be printed here. And this is how iterator works. See, some of you might have expected it to print from 1 to 10 here, but it didn't, because 1, 2, 3 has been exhausted here. So there are two more methods available for iterator, which is for each remaining and remove method. Let's see them. I'm going to remove this piece of code. For each remaining method is a void. We don't have to keep it in a while loop, so we can directly write here. For each remaining, it is accepting a consumer action. So I'm typing here. Now let's see. Yeah, it is been printed. For each remaining can be used to perform an operation actually. So you can also add a function here like apply of n. Then we can create this function. Then in the function, you can add any action on it. As you can see, we are printing the square root of n. For each element, Java will call apply method for that element. Action can be performed here. Now let's learn how can an iterator remove an element from list. So we have 1 to 10 here. So let's remove some of the elements from this list. I am removing this piece of code while iterator.have next. Okay. Then integer n equal to iterator.next of if n oh, then delete. So we are removing all the even numbers from the list. After removing, print the list contents. So we are adding from 1 to 10, and then we are looping through all the 10 elements. If the number can be divided by 2, then we are removing them. So we are expecting 1, 3, 5, 7, 9. That is the output we are expecting. Let's see, I am running the program. Yeah. So as you can see, 1, 3, 5, 7, 9. Now we have learned all the 4 methods provided by iterator. As you can see, we cannot traverse from end of the list to the beginning of the list because we do not have those methods available. Iterator doesn't support such traversals. So let's learn a list iterator and let's see how we can traverse from end of the list to beginning of the list. Now let's see how can we obtain list iterator. So I'm removing this piece of code. List iterator. Same as iterator, we have to give integer f type. For the other list, have list iterator method, which will return a list iterator. So now let's see what are the methods available for this list iterator object. Add, have next, have previous, next, next index, previous index, remove, set method for each remaining. And there are some methods which are inherited. So let's traverse the iterator first, while list iterator dot have next. Then I'm running the program. Here we are checking if there is a next element available or not. If it is available, it will return true. Then that element will be printed here using next method. Now the main part of the list iterator is we can traverse back from the end of the list to beginning of the list. Let's see how we can do that. While list iterator dot have previous. List iterator dot previous. Now let's run this program and see what happens. I'm free to add one line here. So this output is the forward direction and this is the backward direction. Now if I am running only the reverse part by commenting out this line, let's see what happens. So what will be the output of this program? Here the list iterator object has been created. Initially list iterator will be pointing to the first element. So we will see what will happen when we running this program. As expected, nothing. The reason is the list iterator is now pointing to the first element and the first element don't have any previous, right? That's why this loop is not executed at all. Now there is one way. List iterator have two overloader versions. I can show you here. See the second version accepts an index as starting position. So let's add here a list dot 5 of. Then let's run this program and see what will happen. Yeah. So here we are setting list iterator to the last object. By doing so, we can iterate backwards. Now always remember this. Whenever an iterator is created, it is usually pointing to the first element unless until we do something like this. And that iterator object can be navigated from that position, like previous, next index. Now there are many methods available for list iterator here. I suggest you to test with add and fetch and remove method and other methods like next index and previous index. Okay, now let's learn about split iterator. So I am removing this piece of code. The split iterator object can be obtained the same way as list iterator. So I'm just typing split iterator here and then split iter and we can use a list of split iterator. So now we have obtained the split iterator object. So I would like to show you three methods. The main three methods of split iterator. One is try advance, another one is for each remaining, and the third one, the most important, is try split. So first, let's traverse the split iterator using try advance. So while try advance returns a boolean value, so we can use it in while loop. I'm running the program. See, we could traverse the list in a single line. Try advance checks in advance whether the element is available in the list or not from the current iteration, and if it is there, it will return and we can perform an action on that element. Now for each remaining works similar way. Since for each remaining is a void type, we don't have to wrap it in while loop, so I can write directly here split iterator dot for each remaining. So for each remaining and try done is of consumer action, so we can perform an action on each element. So what will be the output of this program? This line already moving the split iterator pointer to the last element. So when we are running this, how will be the output? Let's see. Yeah, there you see. Here this line is not executed. It's executed, but there is no element to be shown. The reason is split iterator is already pointing to the last element. So there are no remaining elements to process. So what we can do is we can comment out this line. Then let's see the output now. Rerunning the program. Yes. Now as you can see, this has been executed. These are the two methods, try advance and for each remaining. Then one more method which is very important for split iterator, that is try split. So try split can be used to split an iterator. So let's see how this works. So I am creating a new split iterator, integer, two. Now we have two split iterators. One is split iterator, which is a split iterator for a list, and split iterator 2, which splits the split iterator. Now let's see the contents of these two. First, if split iterator not equal to null, that means it could split. Then let's print the value. Now let's print the split iterator 2 values. Remaining. Okay, now I'm going to run this program. Now let's see what split iterator 2 object holds. Yeah, 1, 2, 3, 4, 5. See, we are adding from 1 to 10, but split iterator 2 holds 1 to 5. Then what about the rest of the values? Well, actually what happened is split iterator 2 object is split the split iterator object and the data has been divided. Now let's print the values of split iterator object. Same way, I am copying this line. I am changing to split iterator object and now here we are printing the values of split iterator 2 object, and here we are printing the values of split iterator object. So now let's see, I am rerunning the program. As you can see here, split iterator 2 object could split the split iterator object, and split iterator 2 holds values from 1 to 5, and split iterator holds values from 6 to 10. So we have to remember that whenever you are splitting, the beginning of splitted values will be stored in the second split iterator, and the rest, the tail, will be stored in the Iterator object. These are the three main methods for Iterator. Now let's print the characteristics of this Iterator. I am removing this piece of code. Now the characteristics method returns an integer value. If you can see, an integer value has been printed. As you can see here, the characteristics values can be useful when one working with Stream API. Now we are winding up this Iterator section. Hope you are learned well. In the next section, we will be talking about the queues and stacks, and that is going to be a very interesting section. So see you there. Bye.